unit circle definitions. So far with our trig functions, we have been able to stick in any angle. Well, we want to broaden this out so that we can stick in any number. In other words, I want to be able to just stick in the number 10 or the number 27. What the trig functions are going to send out to me is information about a coordinate. Okay, here's how this new definition works. You have some number x that you want to stick into one of the trig functions. What you do is you go to the unit circle. This is our same unit circle, center at 0, 0, radius 1. You start at the point 1, 0, and you apply that wrapping idea. If x is positive, you walk counterclockwise. If x is negative, you walk clockwise. You walk along the circle a distance of x units. We know for us that's not difficult to do because walking x units is the same as rotating x radians in the unit circle. So I walk x units, or alternatively I say I rotate x radians. Either way, I end up at a specific point. I will call the coordinates of that point a, b. Well, here's what the 6 trig functions send out to you. Notice over here that the input is x, the number. The sine function sends you out the b coordinate of that point. The cosine function sends you out the a coordinate. The tangent function sends you the ratio of the b coordinate to the a coordinate. Of course, you know the other three are just the reciprocal relationships. So cosecant 1 over b, secant 1 over a, and cotangent a over b. Now, you're thinking, great, so I have to learn some whole new thing? Not at all. These definitions are completely connected to our previous definitions. To see that, drop a perpendicular here to form this right triangle. This length here obviously would be A. This length here would be B. And I know since I'm on the unit circle, this distance here must be 1. It's the radius of the circle. Well, think about our previous definitions for the sine function. When we did the reference angle definitions, we said sine was y over r. In other words, take the y coordinate, which in this case would be b, and divide it by the r distance, which in this case would be 1. b over 1 is b. It's the same thing. Or our original definition of the sine function, SOHCAHTOA, was opposite over hypotenuse. Well, the opposite would clearly be b, the hypotenuse would be 1, and again, I would get b. It's the same thing. You can try it with the other 5 functions and you'll see they all match. Don't miss the point though. The point here is that we've just discovered a way to use our trig functions in situations that don't have anything to do with angles. Maybe we want to stick in 5 seconds. Maybe we want to stick in 3 miles. We now have a way to stick any number we want into our 6 trig functions. The key is this. Simply think of the number as an angle in radian measure. The number is just a number, but on the unit circle we can act as if it's an angle in radian measure, and that's how we can use our trig functions more broadly. Thanks for watching.